Hi there, thanks for watching this. This is the solution video for the practice test for Module 7. So in the first problems, we're looking at some arc lengths and angles and things like that. Arc measures, I should say. So in the central angle 65, that means the arc length is 65. They are always equal. But the inscribed angle is always half of the arc length. So if the arc is 98 degrees, then the inscribed angle is only 49 degrees. There you go. And then in this one, that same principle holds true here. So half of 124 is 62. So you set your expression equal to 62 and you solve, you get x equals 29. Okie dokie. Next problems there. Once again, the central angle is equal to the arc measure. So the angle TOA right there, that is equal to 140 degrees. That 140 degrees over 360 is the portion of the circle that we're talking about here. So we'll use that to find the arc length. It's that fraction times the whole circumference, which would be 2 times the radius times pi, or 12 pi. So 12 pi times that fraction gives us the arc length, TA, 14.66. The area of the circle, 36 pi, times that same fraction gives us the area of that sector. So that would be, that works out to 43.98. So we're going to use that idea for a sector in this next problem too. This sector of this big circular crop here this is a very large thing. It's 160 feet for the radius of that circle. And so the whole circle is 160 squared times pi. From that, we're going to subtract the area of this sector. Well, the area of the sector is 160 squared times pi times that fraction. So the angle is 35 degrees, so 35 over 360 is the fraction. So this whole area of the sector here is 7,819. The whole circle is 80,425 square feet, and when you do the subtraction, you get 72,606 square feet. Okie dokie. Next page. In this angle, or this semicircle right here, we are given this arc length of arc measure, 48 degrees. That means the angle that is inscribed for that arc measure is 1/2 of 48. So angle A right there is 24 degrees. If you do there's a couple of different ways you can figure out this, but if this whole thing is 180 degrees and 48 taken away from 180 is 132. So this arc up here is 132 degrees of arc. That means that the inscribed angle there at B, which subtends that arc, is half of 32, which is 66 degrees. Okay, so then measure of angle C1 is the same as angle A. They're in the same isosceles triangle here. The radii being equal means those two angles are equal, and so that's the same as A, which is 24 degrees. And for the same reason, C2 is equal to angle B. Okay, so both of these angles are equal to each other. They are part of an isosceles triangle here, formed by these two radii. Angle X is equal to this arc measure here, so that's 132 degrees, and angle Y is equal to that arc measure, or 48 degrees. Okie dokie. Let's look at the next problem about an inscribed quadrilateral. And we're given that angle up there 78 degrees, and this arc measure over here 50 degrees. We're also given that this angle X and this angle 2X. So one of the things that we know about an inscribed quadrilateral is that the opposite angles are supplementary. So that means X plus 2X equals 180 degrees. Well, that gives you X equal to 60. So X equals 60. That's going to be helpful. That means that from this arc here plus this one here, that's going to be 2 times 60, or 120 degrees. So that must mean that arc APB is 70 degrees. So that's that right there. So since this is 78, this angle over here is supplementary with that, 102 degrees. So that means that the arc that subtends is equal to 204 degrees. And so when you add 70 plus 134, you get 204. So that means that arc BQC is 134 degrees. This arc CD over here is since we know that that's 50 degrees and that angle there is 78, that means 156 degrees of subtended arc from angle B. And so 156 minus 50 is 106. So we got 106 degrees for a measure of arc CD. And that completes the whole bunch there. Okay, so let's do the last problem here, which is about finding the area, and perimeter of a pentagon with side length 14. The perimeter is pretty easy. That's just 5 times 14, which equals 70. So the perimeter equals 70. All right, and for the area, I'm going to use that formula. The area equals 1/2 the perimeter times the apothem. Now, to find the apothem, which is this length from the center to the midpoint of the side there, I'm going to use a right triangle. I've figured out the angles inside this right triangle are 54 degrees here for this one, which is half of the interior angle of the pentagon. And so I'm going to use that angle 54 degrees to find A. So the tangent of 54 is opposite over adjacent, or A over 7. When I solve that equation for A, I just multiply 7 times the tangent of 54. That gives me 9.63. Well, that's about all that it takes, because all I need to do now is multiply 1/2 times the perimeter, 70, times the apothem, 9.63, and I get about 337.